The Kyoto Protocol gave us timelines and deadlines that run from 2008 to 2012. The minute we get past December 31st, 2012, we need a new protocol, and it's got to be better than the last one. It's got to have more people, more countries in it. It's got to have steeper targets. It ought to work. So we're going to do all that in one meeting. And it was at that meeting in Montreal in 2005 that the world community, through the United Nations, agreed that the 15th Conference of the Parties was the deadline. Because if you work backwards, you say, okay, we've got to have a new treaty in place, and it's got to be legally binding by January 1, 2013. And it takes a while, as the Kyoto Protocol made obvious, to get these things back to countries and ratify them, back to capitals and parliaments around the world, and then you've got to be able to implement them. You need plans. You need to shift your economy. So it was already selected as a deadline that the 15th Conference of the Parties was a deadline back in 2005. I only go through this level of excruciating detail, and I apologize for it, because there's no context in our media. Suddenly Copenhagen is referred to as the big important climate conference, and it's a deadline. But I haven't seen anything in the media that would let even an engaged and interested Canadian know why Copenhagen meant more than Bali, or why anything meant more than Kyoto, or whether they just all get together and say it's a deadline every year and they never mean it. This is the negotiated deadline to replace Kyoto, and it's less than a month away. And we are nowhere near having a successful agreement. That's one kind of deadline. The more significant and meaningful immediate deadline is, what is the atmosphere telling us about how much more garbage it can take before nothing we do is going to make a difference anymore? Now that's the real deadline, and there was an excellent, I keep referring to the Globe, but there was an excellent letter to the editor last week in the Globe in response to the horrible editorial that had been written, and it was from the leading British diplomat in Canada, Sir Anthony Carey, who's the High Commissioner from the UK to Canada, in which he said, you don't pick new targets. This isn't about, the targets aren't meaningless, and he said, we're not, the atmosphere isn't negotiating with us. Right? This is not as though you can say to the atmosphere, I don't like your offer, I've got a better one. This is about the chemistry of the atmosphere. So let's back up. We know a lot about atmospheric chemistry. We don't know everything there is to understand the almost infinite level of variations within world climate systems. The science on this is enormously impressive. We know a lot more than we knew in 1988, although fundamentally no one, as I said, no one's ever described it better than the scientists did in '88. But one thing that's rock solid is some basic truths about chemistry. And I've often said, this is an issue that's better understood as a matter of chemistry than temperature, because it's clearer, the facts are solid, and there's no budging around these numbers. So if you understand a few things about carbon dioxide, one of them is that the natural greenhouse effect on this planet is absolutely essential to life. So I think most of you will know that. If we didn't have a greenhouse effect, which is that blanket of gases around the atmosphere, around the planet, that trap enough of the sun's radiative heat near the surface that it doesn't all bounce back out to cold, dark space, leaving us as a cold, dead planet. We have just enough of water vapor, methane, another dozen or more gases, to keep the sun's heat near us so that we can live here, but not so much that we fry, and not so little that we can't exist. So no life on Earth would be possible without the natural greenhouse effect. For that to happen, carbon dioxide is the most important gas. There are a lot of others, but it's the it makes up the majority of the greenhouse effect. Although per unit, methane's a more powerful warming gas, but carbon dioxide is the big one in terms of its impact, because there's so much of it. But how much of it is there? And this is where you can begin to understand that it's a very powerful warming gas. Without it, we would not have life on Earth, but the amount that's been in our atmosphere over a very long period of time is actually vanishingly small. So we know that before the Industrial Revolution, the amount of carbon dioxide in our atmosphere has never exceeded 280 parts per million. Right? So picture a million pieces of atmosphere, 280 parts are CO2. That makes the difference between us living here and this being a dead rock. Now, that's, some scientists, those of us who have worked, like Janet and I've worked on pesticides, the pesticide industry would always say, oh, 280 parts per million if it's a toxic chemical. That's nothing. That's like a couple of drops of water in a swimming pool. It's a small amount, but it's immensely powerful and critically important to protect life on Earth. So we've tampered with that. Now, how do we know that we've tampered with it, and why am I so solid on the chemistry issues? We have some remarkable science going on, and it comes from measurements taken from Antarctic ice cores. So we know there's a lot of Antarctic ice core work that goes on. What they do is they can measure fairly exactly how old each piece of ice is. Is this a 200-year-old piece of Antarctic ice? 1,000-year-old? 10,000 years old? 100,000 years old? In fact, they've now accumulated a 1 million year record from Antarctic ice cores. Now, the neat thing about Antarctic ice cores is not only do we know how old the ice never forms 100% solid. There's always some air bubbles in there. And every air bubble is like a time capsule to the atmosphere when that ice formed. And it's like every bit of ice left us a signal. What was like 1,000 years ago, 10,000 years ago, and so on. So that's how we know with certainty that although there's been less CO2 in the atmosphere, for instance during an ice age or following an ice age, than there is today, 280 parts per million was basically the highest level of CO2 over a period, in terms of the published literature, of 660,000 years. And I heard recently from Al Gore that they've done the record going back the full million years, and it doesn't change the statement that there's, in the recorded history of 1 million years of Antarctic ice core data, there's never been a reading of CO2 higher than 280 parts per million. We are now at about 386, 387, coming near 390 parts per million. So that's a more than 30% increase in CO2 by direct measurement. So knowing that it's a very powerful greenhouse gas, it would certainly be, this is why I'm stunned by the fact that the denier industry is able to get anywhere with these kinds of solid scientific facts which are not in dispute. So the amount of CO2 in our atmosphere is more than 30% higher, and the source of that increase is anthropogenic greenhouse gases. Now, anthropogenic meaning caused by human beings, all these greenhouse gases. So where is there room for people to say, well, we don't really need to worry about this because vast experiments with the planet's atmosphere are fine with me? I mean, who would think that that kind of recklessness didn't impose risks? And we are seeing, and the scientific work on this through the Intergovernmental Panel on Climate Change is remarkably robust. They know from all kinds of indicators, whether it's the CO2 increase, whether it's sea level rise, whether it's ice melt, things are moving more or less in lockstep. As the CO2 rises, we're seeing climatic destabilization. Now, bits of what I just told you, you can see how people can take it out of context and go on a call-in radio and show and say things like, well, the idea that human beings are causing all the CO2 problems, most of that CO2 is natural. Yes, good on you there. That's a good point. The natural greenhouse effect was keeping us alive on this planet. Yep, it was natural, and yep, that's most of it. But the problem is the excess. The problem is that we're changing the chemistry of the atmosphere, and we're pumping out CO2 so fast that those natural systems of all the green leafy things on Earth that absorb carbon dioxide through photosynthesis and produce oxygen, that's where we got fossil fuels. That's all fossilized sunshine. It was originally carbon sequestered from the atmosphere by some early, millions of years ago, life form that contained chlorophyll, producing oxygen, creating energy, or storing energy, and hanging onto the carbon. And we've been releasing, through digging up coal and burning it, through digging up oil, through burning it, through digging up natural gas and burning it, we have been unleashing volumes of CO2 that totally swamp the ability of the natural sinks to reabsorb. So that's the basic science, and nobody's disputing any of that.